Hi folks, we're going to take a look at 8B from the Unit 5 Lesson 2 worksheet. So if we recall earlier I did U plus V and I set that up. So now I'm going to do part B, which is U minus V. But just to remind ourselves, we know the magnitudes of U and V and we know the angle between them is 40. So again, just a reminder that when they give us the angle between them, it assumes that we're talking about the two vectors placed tail to tail. Okay, so again, I'm going to draw a very similar diagram here. So we'll call this vector U. Okay, and that has a magnitude of 4. And then I'm going to draw vector V. So I'm going to choose to draw it horizontal since there's no indication as to how I have to draw it. Might as well do it as easily as I can. And the angle between them is 40 degrees, except now we're looking for the difference between them. Now, when you're dealing with vectors given explicitly, like you saw in number 7, well, you would probably do U minus V as U plus the opposite of V. But since the information is given with the vectors tail to tail, I'm actually going to use the other interpretation of the difference between the two vectors. And it's the diagonal, or the other diagonal, of the parallelogram formed by the two vectors. In other words, the one that joins the two tips. And the rule is that you go from the tip of the second to the tip of the first. So tip of the second, since this is V, to the tip of the first. So here we see that it does make a difference whether I'm doing U minus V or V minus U, because I would be getting in the other direction if I was doing V minus U. All right, and so now a lot of what we're going to do is very similar, because I'm still going to use the cosine law here to find the magnitude, but I see that now I'm actually working with the angle that's given. So let's start by finding the magnitude of U minus V. All right, so this is going to be the square root of, well, the square of the other two sides, so 4 squared plus 7 squared minus 2 times 4 times 7 times cos of the opposite angle, which in this case here is going to be 40, not 140 like it was in part A. All right, so let's calculate that here. So we have 4 squared plus 7 squared minus 2 times 4 times 7 times cosine of 40. Okay, and now we'll take the square root. I'm going to do that by taking the exponent 0.5, and we end up with 4.7. Okay, so not surprisingly, based on my diagram, it looks like it should be smaller than what we got before. Now, in order to describe the angle, well, I'm going to do the same thing. I'm going to try to describe the angle relative to one of the other, or the direction relative to one of the other vectors. So I'm going to find this angle here, but I want you to be sure that this is not the angle I'm going to use to actually describe the direction. We'll see what I mean when I get there. But let's just start by finding this theta here. So again, I'm going to use the cosine law instead of the sine law, especially since I've got an acute angle there. I don't want to have to worry about ambiguous case of the sine law. So here we have theta is equal to cos inverse of, so what's my opposite side is the 4. So it's going to be 4 squared minus the square of the other two sides, all over negative 2 times 7 times 4.7. All right, so let's calculate that here. So we've got cos inverse of, open the bracket for the numerator, so 4 squared minus 7 squared minus 4.7 squared, close bracket, divided by, open bracket, negative 2 times 7 times 4.7, and we have 33 point, I guess we'll just call it 33.2. Okay, so 33.2 degrees. But if I want to describe this relative to one of the other vectors, remember, angles are always given when they're placed tail to tail. So all I'm going to do is I'm going to take this vector here and I'm going to place it to the tail of, both vector u and v, but it's going to be easier to describe it from vector v. So what I'm going to call phi here, we notice, is just the supplementary angle to that angle theta that I just found. So it's going to be 180 minus 33.2. So let's just subtract 180. So, oh, sorry, I should have subtracted. I accidentally divided. So 180 minus 33.2. Okay, 146.8. 146.8. So now I can give a final answer. So what I'll say is U minus V is equal to 4.7. And then for the direction, I'm going to say 146.8 degrees from V in the direction of U. Okay, so when we say in the direction of, we mean closest. Like that could also be in the direction of U, but that's the longer way to get there. Okay, so we're going to go in the direction of U, but we actually go past it to get to the vector U minus V. Okay, so to recap again, make sure you're drawing your diagram correctly. When they give you an angle, the vectors have to be placed tail to tail. Recognize that the difference of two vectors is the vector that joins the two tips. Just make sure you're going in the right direction from the second to the first. And then you just use trigonometry to solve and use this idea of giving direction relative to another vector that's there. Okay, that's it for this one.